Ladies and gentlemen, today we'll be converting a string to a number the hard way. Alright, so let's go ahead and do that. So we'll create first a script. So I'm gonna use NVim. You can use VS Code or even Roblox, doesn't matter. So I'm just gonna create a script called tonumber.lua, and there we go. I'm just gonna show up the numbers right there, and let's start. Okay. So local function tonumber. There we go. I mean, of course, by the way, we can use Lua's built-in function tonumber, and we can give it a string of any kind, and will give us back. Let me just save this. Okay. So how I can run it? Of course, using Lua git tonumber.lua, and boom. As you can see, just took that 1, 2, 3 string and converted it into a number. How I can check, basically by doing, for example, +1 right there, and as you can see, it is 1, 2, 4. Nice. Alright, so this is the easy way of doing it, because Lua already gives you a function that can actually do that for you. But you're gonna do it the hard way, as I said. So let's say str, let's choose, for example, 3, 2, 1, let's say, okay? And then let's say local number num equal to tonumber. I'm just gonna be using my function right here. I'm gonna pass it the string. And I could have like just passed directly 3, 2, 1, but it's just to be obvious. But yeah, so print num, and that's pretty much it. Alright, so for my function tonumber, we'll get a text, and then it should return a number. In this case, it's n, right? That's pretty much it. So let's save this up and let's run the script again. As you can see, it gives us a 0 because we didn't actually process the actual logic of calculating the number. So let's go ahead and do that. First of all, we need to loop through all the characters in the string. So for I equal to 1, comma the length of the text, just like this. But instead, I'm just going to put it in a variable called len, do, end. Alright, so local len equal to the length of text, just like that. And then I need to grab in the digit. Basically, I want to get a character from that text and convert it into a digit. So how I can do that? Well, first of all, I'm gonna grab my character's byte. So local char bytes equal to string.byte text, I. If you want to know what does string.byte does, basically, make sure to watch my 30-minute video about it if you really want to go deep into it and really understand what it does. But yeah, for now, I'm just gonna give you a bit of a reminder about it. But yeah, so digit equal to char byte. But actually, before actually doing this, let me show you something first. So basically, string.byte gives us back the internal numerical representation of a character, because computers doesn't know something called a character or text. It does only know numbers. So pretty much internally, what you don't see in the screen is that every character is just a number basically in the background. So for example, the digit 0, or the character 0 should I say, have a byte of 48, a digit 1 have a byte of 49, and so on and so on. For example, uppercase A is 65, lowercase a is 97, etc., etc. So as you can see, there's like 255 characters that we all know and love. But yeah, whatever. Alright, so what this helps us with. Alright, so let's see the digit 0, or the character 0. It will give us a byte of 48. But we really don't need the byte though. We want the actual digit 0. Basically, we have the character, and we want somehow to convert it into a number. How we can do that? because if we just get the bytes, we're going to get 48, which is of course not equal to 0. But what we can do is that we can say 48 minus 48. All right, let me get a calculator here. All right, so 48 minus 48. So basically, the byte that we have, for example, let's say we have the character string 0, then we can say that minus 48, and it's gonna give us 0 basically. But for example, for 1, it's gonna be like 49 minus 48. Oh, wait. 49 minus 48. And it gives us a 1. So basically, whatever characters bytes we have, we can do minus 48. So as when it's on digit 0 or character 0, it will give us back 0. And if it's something else, it will give us that thing. But whatever. So local digit equal to char byte basically minus 0 byte. So the byte of 0. This is basically a constant that I'm going to define up here. So local 0 byte. I can just use that number directly, like 48, but let's just keep things much better. Okay, string.byte 0. All right, cool stuff. There we go. Let's print the digit right now and see how it is. W, and let's run our script, and as you can see, it gives us 3, 2, 1, and 0, but 0 is just the result. So for now, just keep your eyes on this numbers right here, 3, 3, 2, 1. So basically this is 3, 2, and 1. Cool stuff. All right. Now we got the digit from each character, but how we can actually group on all those characters and represent them as a number though? Well, if you don't know already, I'm gonna show something real quick. I don't know if you know it or not. You probably do, but just in case. So we did learn, like in school, when we just start to learn, you know, like numbers. All right, let me see. We have, for example, a table, and excuse my handwriting right here because I'm not using my handwriting, I'm using just a mouse, which is super hard. All right, so we were doing something like this, where you have like 1, you have 10, you have 100. So you have a table, and there is this columns, so 1, 10, and 100, and then let's say you have this number 4, 3, 2, and to get the actual number, you basically go ahead and do 2 times 1 plus 10 times 3, or 3 times 10 plus 4 times 100, right? So basically, the sum of each number times its factor, and its factor depends on its position. That's why it's called positional notation, because each number gets factored or gets multiplied by a certain radix depending on its position. Because right here, 1 we can actually see as 0, 10 to the power of 0, and here 10 to the power of 1, and here 10 to the power of 2. Let me just erase that. All right. Okay, 10 to the power of 2. All right, so 10 to the power of 0, 10 to the power of 1, and 10 to the power of 2. So basically, the exponents right here is just like the position of the number, starting from 0, of course. All right, so as you can see, basically it's the sum of the multiplications, right? And let's actually go ahead and calculate this. So 2 times 1 is 2, plus 3 times 10 is 30, plus 4 times 100 is 400, right? And so what we get is 432, which is of course our number. And by the way, the same thing can be done with binary numbers, for example. This is just a bonus, because it's really the same thing. I'm gonna show you real quick how binary numbers operate too. Where is it? Okay, size, and let's just remove this thing, remove this thing, remove this thing. Okay. Oh man. Okay, let's go back into that thing. Let's go. All right. So instead of 10, the number system 10, we're going to use 2 because, well, in our number system that we use daily, it's from 0 to 9, right? So there is 10 numbers basically. So that's why the radix is 10. But in binary, you can only use 2 numbers, which are 0 and 1. Right? So you only have 2 numbers. So you have to use the radix 2. So 2 to the power of 0, basically 1. And 2 to the power of 1, basically 2. Oh. Okay. And 2 to the power of 2, which is basically 4. So this is basically 1, this is 2, and this is 4, right? And so you can go ahead and fill this stuff right here, but you can only use 0 and 1. For example, 1 0 1, let's say. So right now, how we can actually calculate this into our own numbers, let's see how. All right, so let me just get this out of the way right here. Let's go back. All right, so let's do the same thing once again. 2 to the power of 0 times 1. Basically 1 times 1. Plus 0 times 2. Wait, so 0 times 2. Plus 1 times 4. In binary, basically, if you have a 0, you don't add that number. If you have a 1, you do add that number, basically. For example, this 0 times 2, it just cancel out. It's like it doesn't even exist. But yeah, so 1 times 1 is 1, plus 0, plus 4. So this number right here, basically the binary, 1 0 1 is equal to 5, because this equals to 5. Oh, well, of course in our own number system of 10, but whatever, let's just go back right here. So how we can actually do this? So I'm gonna call, first of all, I'm gonna need a radix, and just to make things even cooler, we can actually tell it radix, okay? And then, so here to number str, we can actually give it a radix, for example 10, which is the normal one. And so right now I'm gonna say factor. Factor is equal to digit times, or actually no, not digit, wait, 10 to the power of radix. What I'm talking about, bro? No. Radix to the power of, oh god. Radix to the power of I. But wait a sec. I right here doesn't start at 0, it starts at 1. So what I can do is I minus 1. So it will start from 0. Cool stuff. Now I have the factor, and I can go ahead and print the factor really, just so you can see it. And boom, as you can see, 1, 10, 100, and 0. Cool stuff. Alright. Now what I can do is n equal to n plus whatever number. So factor times digit. Basically, for example, 10 times to that digit that we actually have got. But yeah. And now I can say w. So basically saving, and there we go. So we got 1, 2, 3. However, here we have 3, 2, 1, and of course we was expecting 3, 2, 1. So why it's reversed right here? Basically because we're reading our characters from in the script, of course, from left to the right, okay? But when it comes to the number system, it should read from here, from the right to the left, basically. So how we can do that, how we can reverse it, we can just go ahead and say, instead of I minus 1, we can go ahead and say len. So the length of the text minus I, that would actually reverse it. And let's go ahead and do this. So as you can see, 321, 321 basically. And there we go. Basically, we got it. Really cool stuff. And also, what's really cool is that we can also use the radix 2, for example. So basically binary. Then we can go ahead and see what's going to give us 17. But however, this shouldn't really be the case, because in binary you can only use like numbers like this, for example. And let's see what's that number represents. It's 43, as you can see. And to just emphasize that, what we can do is to make sure that the digit is actually inside that number system. So if digit is less than 0, or digit is greater than, let's say, radix, then, so for example, if our radix is 2, we shouldn't really go ahead after 2. Actually, it shouldn't be greater than or equal to radix. So basically, if digit is less than 0, or digit is greater than or equal to radix, then we're just gonna say error. And we're gonna say, I'm gonna use string.format. The digit placeholder is not supported in radix. D, okay, because it's a number, so basically getting a digit placeholder or a number placeholder, but whatever. Alright, cool stuff. Now I'm just gonna give it the parameters that it needs. So the digit is digit, and the radix is radix. Cool. Now let's go ahead and say w. Lua git to number.lua 43. It works fine because there's no bad character right there. But if I added like 2, for example, which is of course not in the number system of 2, let's see what's gonna happen there. And as you can see, it gives us an error. The digit 2 is not supported in radix 2 because you can only have from 0 to 1, which is quite awesome actually. Alright, so I guess that was it for this video. And by the way, we can also make sure that radix is less than, let's say, or less than or equal to 10. Or actually, if it's less than 0 or radix is greater than 10, then error string.format. The number system of radix, number of radix whatever, radix 10 for example, is not supported. Okay, comma radix, let's go W, and then let's go ahead and say W Lua GIT. As you can see, the digit 2 is not, oh, let me fix first this guy right here. And as you can see, it works because I have a supported digit like radix. If I say 10, it should work too. So it should give us the same number. Cool. But if we say, for example, 11, which is not supported, then it gives us a number. The number system of radix 11 is not supported. So yeah, that was it for this video. See you later, guys. Goodbye.